Hello everyone, my name is Leijie Wang, and I'm excited to talk about our work on exploring how ML-based flagging systems work in Wikipedia, starting community size, local activity, and disparity treatment. I'm presenting this work on behalf of my wonderful collaborator and supervisor, Haiyi from Carnegie Mellon University. Online communities like Facebook, Wikipedia, and YouTube play an indispensable role in our daily life, but we still see with disappointment an overwhelming amount of hate speech, misinformation, and spam. A 2017 Pew survey found that 4 in 10 Americans had personally experienced online harassment. Therefore, content moderation algorithms are widely used to remove undesirable content. For example, Twitter has adopted anti-harassment algorithms to identify block-worthy accounts. YouTube and Facebook have deployed AI-based algorithms to quickly identify posts that violate community norms. While content moderation algorithms can help remove undesirable content more efficiently, they will sometimes raise fairness concerns. For example, in Wikipedia, community members are worried that moderation algorithms might discriminate against anonymous editors. Some people consider algorithms more objective because algorithms have predefined fixed criteria. On the other hand, some community members also argued that moderation algorithms might inherit the bias from the training dataset and then amplify them on platforms at scale. In our research, we aimed to provide a quantitative analysis of whether and how moderation algorithms influence moderation decisions and fairness in Wikipedia. Wikipedia, the online encyclopedia community, encourages anyone to edit nearly any page. To edit an article, you don't have to register and can instead always choose to stay anonymous. This principle helps Wikipedia grow to the largest encyclopedia in the world. But on the other hand, it also requires the community to detect and remove damaging edits effectively. Therefore, a number of content moderation systems are being deployed. In our research, aimed to provide a case study of how moderation systems are actually used in Wikipedia, we focus on reason change filters, short for reason change filters. This system provides 3 filters, as shown here: may have problems, likely have problems, and very likely have problems. And moderators can choose to use one of them to select and review potentially problematic edits. These 3 edits have different thresholds, which represents different trade-offs between precision and recall. The may have problems filter tends to flag any edit that has any damaging sign. It has the lowest precision, but the highest recall, and it is therefore the most sensitive one. The very likely have problems filter tend to only flag edits that are very likely to be damaging. It has the highest precision, and therefore is the most cautious one. In our research, we are interested in the following 3 research questions. By flagging potentially damaging edits, how does the reason change filters impact the moderation decisions? Second, since the moderation system will surface edits by all kinds of editor groups, will this moderation system help alleviate the disparity treatment between different editor groups, that is, anonymous versus registered editors in Wikipedia? We further would like to investigate these 2 questions in communities of different characteristics, and here we focus on 2 factors, namely community size and local editing activity. What do these 2 characters mean in Wikipedia? There are 38 different language editions of Wikipedia, and we measure the size of a community by its number of new edits every day. For example, English Wikipedia is definitely the largest community, while Dutch and Finland Wikipedia is medium and small communities, respectively. Wikipedia has also increasingly adopted a decentralized moderation approach and relied on local community members to moderate. In general, These local community members are interested in a particular domain and will voluntarily keep a close eye on any new edits that appear in articles in this domain. While there are nearly 200 active editors in the most active article, there's only one editor in the least active articles. Before explaining the research method, I need to first talk about how rhythm change filter works. It is supported by a machine learning algorithm called ORIS. For each edit, this algorithm will give a damaging score between 0 to 1 on the basis of its language features. Then for each filter, administrators have decided upon a threshold before. The damaging score of each edit will then be compared against this threshold to determine whether the edit will be flagged or not. For example, if the threshold is 0.5, then the edit will be flagged as damaging. But if the threshold is 0.9, it will be non-damaging. The may have problems filter has a lowest threshold, while the very likely have problems filter has a highest threshold. Our research method, regression, discontinuity design, takes advantage of this thresholding feature. Before any filter is deployed, we would expect that the relationship between the damaging score and the reverting rate to be a linear relationship. However, after the filter is deployed, edits immediately above the threshold will then be flagged, while edits immediately below the threshold will not be flagged. Then there is a sudden jump of the reverting rates across the threshold. The causal effect of the rhythm change filters is then measured by this sudden jump across the threshold. We then applied the regression discontinuity design in the context of Wikipedia. We analyzed the data from 17 Wikipedia language editions, where all 3 rhythm change filters were enabled by default between 2019 and 2020, and as required by the regression discontinuity design method, we further restrict our analysis to edits whose damaging scores were within 0.03 of the thresholds. As a result, we collected 4 million edits in total, made by 600,000 editors. We then first investigate how this moderation system is used in communities of different sizes. For the may have problems filter, we observed that the jump is only significant in small communities, but for the very likely have problems filter, we observed the greatest jump in large communities. This finding suggests small communities tend to use a may have problems filter, while large communities tend to use a very likely have problems filter. Given the only difference between these two filters is their trade-off between precision and recall. These results indicate that small communities prioritize detecting all potentially damaging edits, while large communities prioritize detecting extremely damaging edits efficiently. We then investigate how this moderation system is used in communities of varying levels of local editing activity. For the may have problems filter, we observed that the jump is only significant in less active articles. For the very likely have problems filter, the flagging effect is significant across all kinds of articles, but the largest effect is due in less active articles. Therefore, these findings indicate that less active articles tend to use all these 3 filters to moderate content, but most active articles only tend to use a very likely have problems filter. It further suggests that moderators in less active articles rely the most on machine-assisted moderation systems, while moderators in most active articles do rely more on manual moderation. We then proceed to answer our second question about disparity treatment. How do we tell whether the rhythm change filters can reduce disparity? Before the filter deployed, because moderators consider being anonymous as a sign of vandalism, they pay close attention to anonymous edits. But if the moderation system succeeds in reducing disparity between editor groups, we would expect that it can surface edits by all kinds of editors, and therefore a greater flagging effect on registered edits than anonymous edits. But as these two figures show, we only observed a greater flagging effect at the may have provenance filter. Therefore, our findings suggest that only the may have provenance filter can reduce disparity treatment between these two editor groups. But why? One possible explanation is that there is a trade-off between moderation efficiency and fairness. The very likely have provenance filter focuses on filtering the very damaging edits, and 95% of flagged edits are made by anonymous editors. As a result, in order to remove highly damaging edits as soon as possible, this filter primarily flags anonymous edits instead of surfacing all kinds of editors. Therefore, we observed a trade-off between moderation efficiency and fairness. In summary, there are three key takeaways. Small communities prioritize detecting all damaging edits, while large communities prioritize detecting extremely damaging edits efficiently. Less active articles rely the most on machine-assisted moderation systems, while most active communities rely more on manual moderation. There's a trade-off between moderation efficiency and fairness. These findings have important design implications for future designers of online platforms. Firstly, we have seen how moderators in different communities use one system differently to take full advantage of the system to facilitate moderation work. Therefore, we encourage designers to empower moderators to adapt moderation tools to their workflow. Secondly, since communities of different sizes have different moderation priorities, designers should support this moderation work accordingly. We have also observed that local moderators play an important role in removing damaging edits in Wikipedia, highlighting the importance of motivating and empowering local members to moderate content. Finally, designers should also remind moderators of the trade-off between efficiency and fairness through the UI design. This is all of my presentation, and thanks for listening.